Hello everyone, welcome to the video presentation on innovative big data management concept. First, we understand what is big data. Big data means data sets so large or complex that traditional tools struggle to handle them. The simplest way to think about it is the 5 V's. First, volume, velocity, veracity, value, and variety. First, volume. It refers to the amount of data being generated and stored. Today's data can range from terabyte to zettabytes. Example, social media posts, online transactions, sensor readings, or surveillance videos. Why it is matters? Large volumes require scalable storage and distributed systems like Hadoop or cloud storage. Second is velocity. It describes the speed at which data is generated, collected, and processed. Examples: live streaming, data from sensors, stock market feeds, or real time app logs. Why it is matters? First, first moving data requires tools capable of real time analytics and rapid decision making. Example: Apache Kafka, Spark Streaming. Third is variety. It refers to the different form of data. Types include structured, unstructured, and semi-structured. Structured means databases, spreadsheets, unstructured like text, images, video, audio, semi-structured like JSON, XML, logs. Why it is matters? Different formats needs flexible tools that can handle all data types. Fourth is veracity. It refers to the quality, accuracy, and reliability of data. Real world data can be incomplete, inconsistent, or noisy. Example: duplicate records or false information. Why it is matters? High veracity ensures insights are trustworthy and decisions are accurate. Fifth is value. It represents the usefulness of data, the end goal of big data management. It's about extracting insights that improve operations, predict trends, or create new opportunities. Why it's matter? Without value, data is just digital clutter. Why managing big data matters? Data without management is noisy. Effective big data management turns raw streams and file into trustworthy information that drives decisions, products, or and operations. Well managed data enables better decisions. Reliable analytics reduce guesswork and guide strategy with evidence. Rapid innovation. Teams can iterate faster when they can access and experiment with clean, integrated data. Operational efficiency. Automation, predictive models, and real time alerts cut cost and reduce downtimes. Stronger customer experience. Personalization and timely insights improve in retention and value. The three foundational strategies of big data management. First, data quality management. Second, data integration. Third, data governance. First, data quality management. It ensures accuracy, completeness, and consistency. Processes include validation, deduplication, and provenance tracking, so analysis rests on trusted facts. Second, data integration. It brings data together from many sources, databases, APIs, sensors into a unified view. Techniques include ETL, ELT, streaming pipelines, and data fabrics. Data governance establishes rules, roles, and controls who can access data, how it can be used, and how privacy and compliance are enforced. Data quality, the three C's to trustworthy data. High quality data is essential. Use the 3 C's as a practical checklist when assessing or improving datasets. First, completeness. Does the dataset includes all required fields and records? Missing data creates blind spots that bias analysis. Second, correctness. Are values accurate and validated? Cross-check with authoritative sources and add rules to catch anomalies. Third, clarity. Is data well documented and standardized? Clear metadata, consistent naming conventions, and unit definitions. Reduce mistakes. Practical techniques, automated validation rules, data catalogs, lineage tracking, and regular profiling. Investing here saves time and prevent costly errors downstream. Advantages Advanced techniques for empowering big data insights. First, machine learning and AI. ML and AI find hidden patterns, classify data, and make predictions. Applied examples: fraud detection, recommendation engines, and demand forecasting. Models need quality training data and careful monitoring to avoid drift. Second, real time analysis. Processing streaming data as it arrives to produce instant insight, use cases, training system, anomaly detection, operational monitoring, and dynamic personalization. Third, data visualization. Visualizations translate complete complexity into actionable views, dashboards, charts, and narratives makes insight accessible to decide decision making across the organization. Big data in action, real world innovations. Concrete innovations show how big data becomes value. Autonomous vehicles, massive sensor streams are first within maps and ML to make split second driving decisions. Data management ensure timely, safe decisions and model updates. Predictive maintenance. Equipment sensors feed models that forecast failures before they occur, reducing downtimes and maintenance cost in industries like transit and manufacturing. Personalizing Personalized marketing, clickstream and purchase history are combined to deliver individualized offers across channels, improving conversion and lifetime value. Each use case depends on integration, how latency, processing, secure governance, and continuous model improvement. The full stack of big data capabilities. Challenges and how innovation helps overcome them. Scalability and storage, security and privacy. First, scalability and storage. Challenges: storing and processing massive volumes, innovation, cloud native data lakes, objective storage, and distributed compute. Example: Kubernetes serviceless pipelines let organizations scale cost effectively. Security and privacy challenge: protecting sensitive data, innovation, role based access, encryption, differential privacy, and privacy prevention. ML keep data usable while reducing exposure. Data quality and consistency. Automated cleaning, enrichment, and metadata catalogs reduce messy data. Data observability tools catch issues early. Operational complexity. Pipelines, monitoring, and reproducible workflow infrastructure as code in simplicity, deployment, and reduce error. The future of big data management. Big data management is evolving rapidly. Expect these trends to shape the next wave. AI driven automation. Automated data pipelines, model building, and anomaly detection will reduce manual effort and speed delivery. IoT and edge integration. More data will be created at the edge, sensors, devices. Hybrid architectures will move processing closer to the source to reduce latency and bandwidth use. Stronger governance and ethics. As data power grows, frameworks for privacy, fairness, and transparent model behavior will be critical for trust and compliance. Semantic and knowledge graphs. Better linking of data with mining will make discovery and integration faster and more intelligent. These shifts will make data more actionable, trustworthy, and accessible, empowering organizations to make smarter, faster decisions while honoring privacy and ethics. Big data management, your key to smarter decisions. First, embrace quality. Build automated checks, catalogs, and inlines so every dataset comes with context and trustworthiness. Second, integrate it thoughtfully. Use streaming and batch patterns where appropriate. Centralized catalog and federated access makes data both unified and governed. Third, govern and protect. Clear policies, role-based controls, and privacy techniques let you innovate responsibility and stay compliant. Fourth, use AI and real-time analytics. Combine ML with low latency pipelines to deliver predictive, automated, and timely decisions that create a competitive advantage. Final thought, effective big data management is a blend of technology, process, and people. Invest in the foundation, quality, integration, governance, and then layer advanced analytics and automation. The result, faster insights, better products, lower cost, and a more resilient organization. That's all about. Thank you.